Section 2.1, working with fractions applications. Before it can be used, a 16-ounce container of liquid freeze fertilizer must be mixed with 96 ounces of water. What fraction of fertilizer is in the final mixture? Okay, so we have a 16-ounce container of liquid fertilizer, and we're going to mix that with 96 ounces of water. And they're asking us what fraction of fertilizer is in the final mixture. Okay, now we do know the final mixture is going to be the denominator because they want to know out of the final mixture, what's the fraction? Well, what's the total of the final mixture? Well, it's simply going to be the 16 added to the 96. That will give you the total or the final mixture right there, okay? So what we're going to do is we're going to say, well, absolute terms, what is the final mixture? Okay, well, we would just add those together, right? So we'd say 16 plus 96, what would that give you? That would give you 112. So that's the total, right? Now, they want to know what fraction of fertilizer is in the final mixture. Well, there are 16 in there. So they want to know, well, if there's 16 out of 112. And notice I keep saying out of. Well, that's kind of how you set it up, right? 16 out of what? 112. Okay, and that kind of tells you how to set this up, right? The out of part is going to be on the bottom. That's out of the total, right? The total's on the bottom. And the part is going to be on the bottom. So sometimes I write it as part over the whole, or the total. Or you could write part over the total, right? So that's the basic concept of the fraction, right? So what was the total in this case? It was the fertilizer plus the water. And then what was the part that we're interested in? Well, they say what fraction of fertilizer is in the final mixture, which was the 16. Now, we're not done because it looks like 16 over 112 will simplify. And you have a couple of ways of doing this. We'll still focus on the first way, though. So can we divide by 1? No. Can we divide by 2? Yes. Now, you do want to normally divide by the greatest common factor, which is the largest number that you can divide both to the numerator or denominator. But I do want to point out that if you divide both the numerator and the denominator by a common factor, even if it's not the biggest, a common factor, you can, in fact, chip down on these fractions, and eventually you will get the correct answer. So, for instance, 2 was not the greatest common factor, but it did allow me to shrink it a little bit, and then I could just simply, oh, they're both divisible by 2 again. Fair enough. Which gives me a 4 over 28. And then, oh, well, I can divide these both by 2 again. And that gives me a 2 over a 14. I can divide these both by 2. Oops, 2. And that would give me a 1 over 7. Now, do I recommend you do it this way? Not really. But I do want to point out that, yes, if you don't find the greatest common factor because the numbers are getting a little out of hand, that's okay. You can still simplify them finding a common factor and then chipping away at it. This is really just a modification of prime factorization, which is the second main way of doing it, which is, we'll get more into prime factors later, but basically you want to break it down into prime numbers. This is way more complicated than necessary, so I don't really deal with this. But basically, prime numbers are numbers divisible by the one in themselves. And this is just a preview for, it gets more complicated later on. So just as a quick preview, you don't need to know this right now, but it is a quick preview. So prime numbers are things like 2, 3, 5, 7, so on and so forth. The reason I don't have 4 as a prime number is because I can divide 4 by 2, right? And the reason 6 is not included in a prime number is because I can divide 6 by 2 or 3. So prime numbers are numbers divisible only by themselves and 1. I can divide 2 by 2 and 1. I can divide 3 by 3 and 1. I can divide 5 by 5 and 1. I can divide 7 by 7 and 1. And that's it, right? So what about 8? Well, 8 wouldn't be a prime number because I can divide 8 by 2 and 4. What about 9? No, 9's not a prime number because I can divide it by 3. What about 10? What about 11? 11's a prime number. What about 13? 13's a prime number. What about 17? 17's a prime number. What about 19? 19's a prime number, so on and so forth. There are an infinite number of prime numbers, but that's how you'd find the prime numbers. And basically, a prime factorization is you break it up into a series of prime numbers that you can multiply together to get back the original, right? So 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's the prime factorization of 16. Okay? Now, the way you'd actually write out this process, and again, this is all just a preview for what's going to come later on, so don't panic yet. But this may be necessary later on, so I'm just going to break it down, right? So 2 goes into 16. Yes, so I divide by the first prime number that's listed as a 2. So I divide it in there, and I get a 56. And then I try 2 again. I get a 28. I divide by 2 again. I get a 14. I divide by 2 again. I get a 7. I can't divide 7 by 2. I can't divide it by 3, I can't divide it by 4, but I can obviously divide 7 by 7, which gives me a 1, which gives me a prime factorization of 2 times 2 times 2 times 2 times 7. At that point, you would just cancel out the numbers that are the same, and when it cancels out, it actually turns into a 1. So there's still a 1 on top. It gives you 1, 7. Now, obviously, the first one's probably easier on especially simpler problems, but in case things get really complicated, the second method really works for really complicated problems. If that confuses you, if you don't like that, do not do it that way. Your calculator can simplify fractions, add, subtract, multiply, and divide fractions. Fine. And you are all allowed to use a scientific calculator in this class. You are expected to know how to use the technology. If it's taking you forever because you're doing everything manually, you're probably doing it wrong, right? So again, use the technology. It's okay. You're allowed in this class. We want you to get proficient with the use of the technology so that this gets as easy as possible. Okay, so let's move on. So the answer to that was the 1 out of 7, or 1/7. Okay, let's try the next one. A 3/8 inch drill bit is too large for a job, and a 5/16 inch bit is too small. What size should be tried next? Okay, so, I mean, you're probably counting by 16ths at this point, right? So let's try that. So the 3/8 is a bit too large. Okay, so 3/8, which is the equivalent fraction of 6/16. And the other one that we have here is 5/16. Okay, so first, I just did that so I can easily compare them. So I'm comparing a 16th, I'm comparing a 3/8. Yeah, 3/8 to a 5/16. Now, what's the difference between these two? Well, it can't be a 16th difference because we're counting by 16. So this is actually going to have to be a 32nd inch difference since we're dealing with the U.S. system, common system. So I'm even going to multiply this by 2 again and get down to the 30-seconds. And now we're dealing with 12 30-seconds. And this over here, multiplied by 2, multiplied by 2. So we can directly compare these. We're dealing with 11 30-seconds. So a 3/8 inch drill bit is too large for the job. Okay, so this one on top is too large. This is too large for the job. And the other one's a bit too small. So this one's too small for the job. Okay, so we want something in between. Well, we have a 12 30-seconds on top. We have a 10 30-seconds on the bottom. How do we compare these? Well, it looks like we want something in between. So it looks like in between would be what? Well, it'd be an 11 30-seconds, 11 30-seconds. Now, normally on the computer, I think this is just listed out as options, so you just kind of have to get a feel for it. Now, another way of doing this, if you don't want to direct compare these, is you can get a decimal. Decimals will make your life easier in this case. And what I mean by that is, if you're given a multiple choice, I can divide 3 by 8, and that'll give me 0.375. And I can say 5/16, and that gives me a 0.3125. And if you have a whole bunch of fractions, you could turn them into decimals and do a comparison. So you could do exactly what I did over here on the left, but you could do the same thing with decimals. And then you'd be like, oh, I'm going to go through all the options with fractions, turn them all into decimals, and then compare and find the one that's in between these two numbers, right? So that's another option. So if you don't like the fractions, just turn them all into decimals, compare all the decimals, and you do the same process, but you'll end up with a decimal equivalent right there. And the decimal equivalent of that would be something like 0.34375.